Okay, so the next step is to check this reference. This is the reference we're going to check. And this is the CNT, the output of the counter signal. And we're also gonna add the output of the comparator to see if those are correct. So we go back to ModelSim. We already have the reference here and the counter, the output of the counter. We're gonna add the output of the comparator. And if we see here, we have 25 bits signals, and we don't want to check each bit. So what we can do is we can right click on them, click on radix, and select unsign. With that, we're going to change all the bits to the decimal representation of it. We do the same for the output of the counter, unsign, and then we have that as the count, the current count. What is going to happen is when this value on the output of the counter is equal to the reference value that we have selected, this should be a 1 to be given to the FSM. So we go and restart the simulation, click OK, and then we run all. Okay. If we can see, then we have the reference as 14,400 for this case, and it's gonna be different for all of you. Maybe just a few cycles for this part, and the counter is incrementing every clock cycle, global clock cycle, and once we reach the 14,400, we can zoom in there. Once we reach that, you can see when both are the same value, then the output of a comparator should be 1. So that's the other thing you want to check. And the counter should go back to 0. And at this point, the value of the clock of the 1 second clock signal should be back to 0. So that happens. So it is working. So, but assuming your counter is not working properly, then we want to check then if you have a reference connected properly and your counter is not counting, you're getting red at the output, and your comparator is not working. Of course, if your counter doesn't work, then we want to check that the counter is getting the correct signals. So we go again back to our component, and then we want to check that the counter um, is getting the correct reset. And so we go back to our, we can check the code. In the instantiation of the counter, we want to check that we're giving a proper reset and that our enable is becoming 1 when we need it. In my case, I just set it to 1 all the time in this case, and I want to check the internal reset. This internal reset is the creation or the combination of the global reset right here and a count reset that comes from the state machine. So that count reset comes from this state machine here, and I have the combination with an OR gate because I want to reset the clock either when the FSM tells the counter to reset or when a global reset coming from the outside of the design tells the whole system to reset. Okay, so we want to check this internal reset that is connected to the reset of the counter, and we want to check the internal reset to see if we're getting the reset properly. So we go back to our wave. We have here the internal reset is this one. We want to check the count reset, and we already have the global reset at the beginning. Okay, so we restart again the simulation, and then we run it again for 100 micro. So if you see, we can check at the beginning all the resets. So our enable is always 1. If you don't have an always 1 enable, you want to bring that into the